Hello everyone, welcome to the study online. So we are going with the Java classes. So already the four classes I have taken, the day 1, day 2, day 3, day 4, which happens to be the demo classes. The day 4 happens to be the combination of two classes, which happens to be I have taken almost 2 hours. So in today's class, I would like to continue from the discussion from wherever I've stopped. So let us quickly go back to the notepad and revise the things. And I would like to tell it as notepad. And let me go to this and let me share the screen. So this is the notepad which you people can see now. So let me quickly type it as maybe I like to write it in caps. I would like to write it as Java day 5 and we were discussing about, maybe I would like to tell it as in Java day 4. So we were discussing with respect to the maybe the Java features. So this is what we were discussing. So if you have not watched the, if you have not attended the class, and if you have missed the class, it's present in the YouTube. So you can check it once, go through the things. So I have done 7 features already in that. So let me quickly recap the things I have explained about what do you mean by the platform independent. So platform independent is what I've done, and the platform is nothing but the operating system. In all the operating system, your Java program should work. That is what platform independent. People will call it as the right ones and run anywhere. Aura. That is what already we have discussed in the last class. And it is one more feature that happens to be this is interpretive in nature, or people will also call it as byte code, because first time this is the language which has shown. So rather than going for the machine level language directly, how you can go to the intermediate level language, that is byte code, and how you can achieve the platform independency. So let me consider one more thing. This is very simple compared to the C and C++. All the confusion topics has been removed, like multiple inheritance and the pointer concepts and all those things. So this is also architectural neutral, which refers to the when you change any things in your computer, so it will not affect the Java programs which is running. That is what I can tell. So next point that we were discussing. So after the architectural neutral, we were discussing about what exactly, let me click here, what is exactly portability. I would like to call it as what is this portable. As I told, if any programming language, it is portable in nature, that means it is platform independent. So if it is a platform independent in nature, it should be a portable programming language. So it is like a two face of a same coin. So all those things we know, that from one computer to one more computer, you can easily transfer the code. That is exactly the byte code, and you can execute in any computer. So, and after this we have also seen the basic definition or the introduction to words. So what is this object oriented, and what is the difference between the structured program and the object oriented program. So all those things we have seen, and I've give you just a glimpse on what do you mean by a thread. So in that, what do you mean by a multi-thread. So what do you mean by this multi-threading concept? So that is not the complete concept. So multi-threading itself is a different topic altogether in Java that I have to explain in detail with some diagrams. This is what I have done for my last class, and today I have to explain a few more features of Java, which happens to be this is robust in nature, and this also happens to be distributive. So I would like to tell this happens to be distributive or distributed in nature. And one more thing happens to be, so it will give you the high performance. So it will give you the high performance, that is what I can tell. So not only that, This programming language is a dynamic programming language. So whereas the C, C++ or the static programming language. So I can tell it as this is secured programming language. So why these points I'm telling, so you'll be understanding. So in order to explain the Java features from 8 to 12, so before going for that part, I would like to take up a concept. So using that concept, I would like to explain all these things. So let me take up a brand new concept now. So what is the brand new concept that I'm going to do it for today in order to explain the remaining features? If you ask me, I would like to explain the Java softwares. So what is this Java softwares? What are this available? The notes point, all those things I'll be giving. Quickly we'll go to the screen, the whiteboard, to write some diagrams, and let me explain what are the Java softwares that are available. So I would like to write it in this way. I would like to write it as Java softwares. Maybe I would like to do less colon. Let me increase some font size, and let me show it in a different color altogether. So this is the Java software. So Java software, internally, when you download the Java standalone edition, you'll be having two types in that. So what are the two types? Now we'll be understanding. Now just watch this carefully. So I would like to consider these are the two things which are available. So first one, I would like to consider it as JDK. Sir, what is this JDK, sir? Maybe you'll be getting to, you'll understand what is this JDK. One more thing happens to be the JRE. Sir, what is this JDK? What is this JRE? If this thing's in running your mind, observe now carefully. The JDK stands for Java Development Kit. So this is what we are going to call it as JDK. Sir, what is it actually? The full form happens to be Java Development Kit, but is what is exactly the JDK? In a couple of minutes you'll be understanding. So let me reduce this much of font is not required actually. So let me consider to 12. It's okay. So I'll take it here. So in the same way, I'll take one more text and I would like to like it here. So and I will tell it as this happens to be Java runtime environment. So by seeing this word environment, don't think that I'm going to do some environmental study here. So I'm going to do some earth atmosphere, lithosphere. Don't think on that. So it is purely about the Java itself. So now let us see what is exactly this JDK and JVM is all about. So let me consider a software. So if I want to develop a software, so in this suppose I want to develop one software. So whatever the software I'm going to develop, so the same software I'm supposed to execute it. If you want to develop as well as if you want to execute, then you require this JDK. So I can tell it as you require the help of the JDK. So in case you are not developing, you are the end user, you are just going to execute the programs which is given by the Mark Zuckerberg or any Java developer. If they have given the program for you to execute, then your aim is only to execute the Java program. So I would like to tell it as you're going to execute it. And for the execution, so let me consider here. So I would like to tell it as here you required, let me cancel this. I don't want this. I would like to consider here happens to be I required the JDK as well, plus I required JRE. The development kit is also required to develop, and the runtime environment is required in order to run the program. So I would like to consider this one. So here I required only JRE, Java runtime environment. Runtime environment, that means if I want to run the program, I required environment. So this what we are going to call it as JRE is sufficient. uh, Sir, what exactly JDK is all about? What do you mean by JDK? I'm not getting the point. Have you seen any carpenters working? Have you seen any mechanic working? Or have you seen the cricket players? So these people all always they'll be there with their kit. If you see a carpenter, if you see a plumber, if you see any mechanic, and if you see, any cricket player, they'll be with the cricket kit or with the toolbox, especially the mechanics. Why they'll be with that? So without that, they cannot perform the work. So inside the kit, if you open the bag, so many things will be there. In the cricket kit itself, you'll be having hand gloves, you'll be having leg pads, you'll be having abdomen guard, you'll be having the helmet, so bat, ball, gloves, if you're a keeper, so many things will be there. In the same way, if you go to any plumber, if you open the box, or mechanic, some screwdriver, spanner, maybe nut and bolt, so many the things required to do the work, it will be there in that. In the same way, what is this development kit, which is present with respect to Java? If you ask me, it is Java development kit, the kit which has been used in order to develop the Java application. That is only we are going to call it as Java development kit. So then, what is this Java runtime environment? Java runtime environment is nothing but, so the environment provided by the Java during the runtime, during the execution of the program. That is what we are going to call it as Java runtime environment. And whatever the program you had seen, ultimately in my previous classes I have spoken about something called as JVM is a platform, dependent one, and it is a interpreter. So all those things I have told, right? So if I want to explain about that, so let us quickly tell you the program execution. So I would like to consider as normal the Java program. One simple Java program is what I'm going to consider. Maybe I would like to tell it as this is the Java program. So this is my Java program. So when the Java program is available, so you know that we are going to give it to whom? We are going to give it to the compiler. So I would like to give it to the compiler software. So here is my compiler. So let me consider this happens to be the compiler. Let me consider it as the compiler. So okay, if you give it to the compiler, what will happen? You know that he is not going to create any machine level language directly, because you know that in this case what will happen. So we are going to get the something called as byte code or intermediate code. So I would like to demonstrate the same thing here. I would like to consider this happens to be the byte code which I'm going to get. So let me consider this happens to be the byte code. I would like to consider it as byte code. So once you have the byte code, so, or I can also call it as a class file. So this is what you're trying to load it finally to the RAM. I would like to consider like this, and I will showcase the RAM now. So let me consider this happens to be the RAM. To the RAM you're supposed to load it. So once you are going to load it, so you will give it to the microprocessor, and that fellow I will always call him as the boss of the computer. So I would like to call this happens to be the microprocessor, and he's going to provide the output, which you already know the story, so I need not to tell it again and again. So but the thing that you should be understanding from this particular diagram happens to be, so when you are going to load, so who is actually going to load into the RAM? So what will happen in the background? So that is what you should be understanding carefully. So bytecode is there. Now I'm supposed to load it to the RAM. If I want to load it to the RAM, what and all things will happen in the background where the JVM is present? That is what we are trying to understand now. Do observe carefully. JVM is the interpreter who is going to load your class file onto the RAM. So JVM is going to act like an interpreter also. The JVM only is going to act like the loader software also. Maybe in my previous class, when I take up the C and C++ as the example, I've spoken about the linking software and loader software, where linking software is going to link all the predefined libraries of the C programming language, and loader will load the executable file onto the RAM. But in this case, the JVM is going to do all this task. So let us go to this particular RAM and see how the JVM is going to work. And in this software, I'm telling JDK and JRE, where is the JVM is present. That is what you should be understanding now. So if you want to understand that, I would suggest quickly to take the screenshot of this particular diagram. So let me quickly go to the next page. So here I'm going to explain what is present inside the JDK and where actually our JVM is present. So I would like to consider this happens to be maybe the JDK. So I would like to consider this happens to be JDK, and within this I would like to consider one more thing. This one more thing itself, we are going to call it as JVM. So I would like to call it as this happens to be the JDK for us. So I would like to call this happens to be the JDK, and this is what is our JVM. So I would like to write it here. This is JVM, the Java virtual machine. So JVM will not only perform one task, it will be doing multiple tasks in the inside the computer. So this is my JVM. So if I want to take, JVM, I'll be taking inside, because inside the JDK, what you're going to get means you're going to get something called as JRE. So I would like to tell it as this is my JRE. Within that, you'll be having the JVM. So within that you'll be having the JVM. So I would like to represent like this. So and after which I want to take this as well, and I would like to represent here. So when you download, what you're going to actually download, if you ask me, you cannot download the JRE directly. The Java development kit is what you're going to download. The JDK is what you're going to download. And when you're going to download the JDK, and inside the JDK, what will be there? Inside the JDK, JRE will be there, the runtime environment, and inside the JRE, you will be having the JVM. And not only that, along with this so-called as JRE, what are the other things that will be available inside the JDK should be understanding. Now observe carefully. What are the other things that will be available? I'll be writing it now. You'll be also having something called as developers tools. I would like to call it as developer tools. Sir, what are these developer tools? Maybe example, if I want to tell, so I can tell like this. You'll be having something called as Java C, the Java compiler, and you'll be having something called as Java doc for documentation, and you also will be having the Java executable file here to execute the Java program. So all these things are available. Just examples is what I'm giving. These are what we are going to call it as developer tools. So I would like to take it as uh, here the plus mark. So I would like to tell it as developer tools will be there. And here also, along with this JVM, what will be there, if you ask me. So I would like to consider it as this. So and I would like to consider as JVM, and along with that, you will be having the library library classes will be there. So what are the library classes? For example, if you ask me, in the C programming language, you only told that hash include. You include what and all you should include. Predefined the header files is what you're supposed to include. stdio.h, conio.h, match.h, whatever the header files you want. .h, the header files is where you would including. Here in the Java, there is no concept of header files. No, there is no concept called as predefined libraries. Here you have something called as packages. Whenever you are typing something, you will not code for many of the things. Just you are going to take that and you're going to use that. Examples, maybe if I want to tell now, I can take it as, you will take it as java.lang. You will take it as java.util. So what is this? All those things, don't worry. Maybe when I take up the concepts, in detail with the program, you'll understand. But as of now, these are the library classes that are available. Not only this, so many things are there. Just I'm giving you a few example. So many library classes will be there. So all those things is put it together is what we are going to call it as our JDK. So quickly, if I want to sum it up, I can tell like this. So what is JDK? If someone asks you, you can easily tell that the JDK is a combination of you will be having JRE plus you will be having something called as developer developer tools will be there. I would like to tell it as you'll be having developer tools. So developer tools means the compiler will be there, the documentation and the executable file, all those things will be there. And in case someone asks you in the JRE what will be there, you can tell it as JRE equals, you can tell it as a JVM will be there, plus along with that you will be having the library classes. I cannot tell it as library files here, I will tell it as library classes will be there. Is that clear for everyone? Is that clear? Not only that, you can get many different editors in order to type. I would like to consider it as text editor here. I would like to tell it as a text editor. Maybe the suitable name I'll give, not this. I would like to tell it as IDE. So what is this IDE is all about? I hope people will call it as integrated integrated development development environment. So this is what people are going to call it as integrated development environment. Sir, can you give me some examples if you tell me? So I would like to consider this. Let me change into a different color. I would like to tell it as integrated. Okay, so let me select all this. So I would like to consider examples for this. I would like to take the text and I would like to tell it as, so you can do it with Eclipse. So you can do it with the Eclipse, or you can go with the Notepad plus plus that is available. You can also have something called as Edit plus. Maybe in the beginning I'll be using the normal Notepad, and after that I'll go with the Edit plus, and finally I'll go with the Eclipse. So let me reduce the font of this. Let me change it to the red color. So these are the IDEs I'll be using. So if someone asks you what is the Java software, I can tell that Java software has been present in two ways. One is for development and execute, you can use JDK, and only for the execution you can use JRE. And what you download from the internet, if you ask me, you are going to download the JDK, that is Java Development Kit. In that, so many versions are there with respect to the standalone edition. You can go for that. So I'll be using the Java 8, which is the legacy, which has most features. And inside the JDK, what and all will be there means Java runtime JRE is present inside the JDK, and along with the developer tools will be there. But what is there inside the JRE? If someone asks you, inside the JRE you'll be having the JVM, and you will be having some of the library classes. So what is the duty of JVM is what we should be understanding correctly. And before understanding all these things, so I want you to give some note point, so then only I can proceed with the Java architecture. Exactly what and all things will be there inside that JVM. I want to explain. So of the small box, can you see here? What are they present inside this? If I want to explain, I have to give some notes. So I'll go for the notes part. So let me give you some points. So I would like to write it here. So I would like to share the screen with respect to the notepad. So, and I want to write it here. I would like to tell it as Java software. So is divided into two types, or I can tell it as divided into two parts. Can you name them? Yes, the first one happens to be, I would like to take it as the first one happens to be JDK, and the second one happens to be, we are going to call it as JRE. Very good. So JDK is what we are going to consider first. I would like to rate it as JDK is a Java development kit. So JDK is a Java development kit used for, or I can tell it as directly, it's used by whom? It is used by Java developer. It is used by Java developer to develop, and execute Java application, I would like to write it as to execute Java application. Fine. So next, I would like to tell it as the same JDK is consist of consist of JRE, JRE, and you tell me what is consist of developer tools. Very good. Not only that, now let me tell it as about JRE. JRE consists of, or JRE is used for, I will tell. So I would like to tell it as JRE, which consists of JVM and what it is consist of library classes. It is consist of library classes. Whatever the JRE that is present, the JRE is used for execution is used for execution of what? Execution of the Java software. If you want to develop, you'll use JDK. If you want to execute, once you develop, you have to execute, right? So for execution, you'll be using the JRE. So now let us go to the what is the JVM is all about. So I would like to tell it as JVM is a Java virtual machine that you already know that. So JVM that provides that provides environment environment to execute Java programs by converting converting what it will convert. It will take that byte code, it will convert by converting byte code into native code. I would like to call it as native code. What is this native code? It is nothing but machine level language. Okay, so jvm this you should never forget in your life. So jvm is part of JDK or JRE, both, but actually it is a part of JRE. This you should be remembering it correctly. Is that clear? Is it clear for everyone? So let me quickly go back to the screen and let me continue with the next one. What is actually present inside the JVM? So let us see now. So I will take up a new page now. So after taking up the new page, I would like to give the heading here. I would like to tell it as overview of Java architecture. So this is a simple heading I'm giving, not the in detail architecture, just a overview is what I want to give it now. So let me explain few points related to the JVM. So in this I want to write the Java execution, which you already know in detail, but I want to explain what is happening on the RAM, and inside that what is happening exactly in the JRE, inside that what is happening with respect to the JVM. So I would like to call it as this is some high level programming language, or I would like to call it as this is only the Java program. I would like to call it as this is only the Java program. Let me reduce the size. So I would like to call it this. Okay. So once you have this so-called as Java program, what you're going to do? So you will give it to the compiler again and again. I'm saying the same thing so that it will sync in your minds correctly. So I would like to tell it as I would like to take the compiler. Which compiler? Any some other compiler you will take? No, right? You will take the Java compiler itself. I would like to call it as this happens to be the compiler. So once you give it to the compiler, what will happen? This fellow is going to create bytecode, intermediate code for me. So I would I'm repeating the same thing in all my classes so that it will perfectly sync to your mind. I would like to call it as I got the byte code. So what next? If you ask me, this byte code has to be loaded onto the RAM. So who is going to do all those things? And whatever the additional things are there, it should be added here itself for the packages. So who is going to do all those things? Now observe carefully. JVM is going to do all those things. So how is going to do? So listen carefully. I would like to consider this as the RAM. So I would like to take the text here. So this happens to be the RAM. So let me change it here. So in this RAM, now I will get, when I have the JDK, so to execute the Java program, what I required, very good. So I required the Java runtime environment. So the Java runtime environment is what I'm going to consider here. Do observe carefully. So I will take like this. Let me consider this happens to be the JRE part. So I would like to consider it as this happens to be JRE. So inside the JRE, what will be there? Just now, I've explained that inside the JRE, what will be there? JVM will be there. Along with that, you have library classes. So I would like to consider the JVM now. So inside this, I'll elaborate and write it here. So library classes, I don't want to write it. So inside this, I'll be having something called as what? So here I'll be having the JVM. So when I have this JVM, so let me put it in a right place. So this is my JVM is present here. So inside the JVM, what and all will be there, that is what we are going to understand now. So this byte code is what we are going to call it as class file. The class file I'm going to consider here. From here onwards, you should be listening to the class very carefully, otherwise you will not get the point. So I would like to consider is happens to be the class file. So inside the class file, what will be there? Generally, a byte code will be there. So that also I'll consider. I would like to tell it as this happens to be the byte code. So byte code is present, fine. Sir, what next? If you ask me, do understand the things correctly from now on. So I would like to write it in a different ink altogether. So I'm going to consider this. One fellow will be there inside the JVM. Sir, who is this fellow, sir? If you ask me, this fellow only we are going to call it as class loader. Uh, Inside the JVM, this software will be there. This particular thing will be there. What is this class loader? What is the duty of the class loader? The duty of the class loader is duty is to act like a loader. Whereas in the C++ separate system software, there is called as loader. In the same way, JVM only acts like the class loader. What is going to load? It will take the class file, that is byte code, and is going to load to the RAM. So loading duty also is only doing. And along with that, one more fellow will be there. So here itself, so that one more fellow within the JVM is what I'm going to call it as byte code verifier. So byte code is there with me. I have to verify it, right? So I'm going to tell it as byte code verifier. Sir, what is the duty of this byte code verifier? Byte code verifier is going to act like a inspector. What is the duty of the inspector? He is going to inspect, right? He is going to check you, right? So whether you are a correct person or a wrong person or not. So in the same way, bytecode verifier duty happens to be whether the bytecode which is generated by the Java compiler is correct or not. That is what the duty of the bytecode verifier. He will check whether this bytecode is correct or not. Is that compiled by the Java compiler only or by some other compiler is going to check. So complete inspection, or whether whatever any virus is present in this bytecode or not, in detail is going to check. That is the duty of the bytecode verifier. Is that clear for everyone? So apart from this also, so many other things will be there. So as and when the time comes, I'll be explaining. But one more very important thing which I want to explain here happens to be, let me consider this, and especially for the execution is what I'm trying to tell. So I would try to write like this. Sir, what is this, sir? Inside the JVM again you are writing something. If you ask me, I would like to write it as this is nothing but the for execution what is present inside this JVM. If you ask me, you have something called as execution engine. Sir, what is this execution engine? Sir, what all things will be there inside here? If you ask me, now understand carefully. Here you will be having something called as interpreter. I would like to write it as interpreter. So I would cancel this one. Let me take it in the same way. So I would like to write it as interpreter. So this is my interpreter. So, what is the duty of the interpreter? I need not to tell it again and again. You already know that JVM is going to act like an interpreter. That means what? Line by line, line by line, line by line is going to convert into the native code. That is the duty of the interpreter. So, after that interpreter, you have one more thing called as this is what is very important for the today's discussion that you should be remembering. I would like to title it as JIT. Sir, what is this JIT, sir? This is nothing but just in time compiler. So this is called as just in time compiler. Sir, what do you mean by just in time compiler? So what is the duty of this just in time compiler? So don't worry, now I'll be explaining. Observe now carefully. So I would like to consider an example here. So in this, assume that this is a Java program. So here you'll be writing some function. I would like to tell it as you have written one function here. So after writing which, so you have written some piece of code as well. I would like to consider you have written some piece of code. So after which, so again you have some set of piece of code. So again, what you are doing, you are calling the same function. You are calling the same function. Please listen carefully. I would tell it as you will call the same function. So after calling the same function, also what will happen? Some piece of code line you are going to write. So again, you are going to write something. So after doing this, what will happen? Again you are going to, I would like to write it here. So again you are going to, after a few times, you will be calling the same thing. You are going to call the same function again. I would like to call it as you are calling this fun. So I would like to tell it as same piece of course again and again you are writing, and again you are calling this fun function whatever it is present. So I would like it as you're doing the same piece of code. Maybe at the end, so you are closing it. Okay, fine. If this is your program, you only tell me, by seeing this. So first time, whenever I am going to get any function, so whenever I'm going to get any method, or any program, so the piece of code, so what will happen? The Java compiler will convert into the byte code, and the interpreter, line by line, line by line, line by line, line by line, first line, second line, third line, fourth line, the complete line of code with respect to that particular function, it is going to interpret line by line, and it is going to convert into what? It is going to convert into the machine level language. Yes or no? So whenever it is going to convert into the machine level language, fine, everything was working fine. But next time when you call the same thing, again the process will go to the same place, right? Yes or no? So I would like to tell it as from here you are calling to the same function. So whenever you are calling to the same function, what will happen? So again it will go to the fun one from the line one. Again it will be keep on interpreting first line, second line, third line, fourth line. I am speaking about the JVM. So again here also when you tell the same story, so it will come to this place and it is going to check again the interpretation. Don't you think once you have checked it whether it is working fine or not? So again and again do you want to go for the interpretation? It is not required, right? So they have kept this particular thing called as just-in-time compiler. So what is the duty of this JIT? If you ask me, just-in-time compiler is very intelligent fellow. Just-in-time compiler will make use of his friend for the help. Who is that friend, sir? One more fellow you're introducing. Now observe carefully. I'm going to call this as the profiler. Sir, what is the duty of the profiler? Profiler will be watching all these functions. If any piece of code is calling again and again, maybe first time when you called, this is called as a zeroth time. And after that, what happened? You called it first time. So I will tell it as next you called it once. I would like to tell it once. So after that, you called it twice. So whenever you have this type of things, I would like to call it as one is over, zero is over, one is over. When you are calling for the twice, second time, immediately what this profiler is going to tell for the just-in-time compiler, this piece of code is already checked, you need not to interpret again and again. Rather than what you do for the second time, if someone calls this particular function, directly you convert into the machine level language. Instead of converting line by line, in one shot, indirectly you are going to convert into the machine level language, so that the speed of execution will be increased, right? Yes or no? That is the main duty of this particular JIT. That is what the main duty of this JIT. So what I will be doing, so again, if I call that particular function also, no issues. So what will happen? Already this has been activated. Directly it will be converting into what? The machine level language. Now observe carefully. So whichever the piece of code, so multiple times, if it is calling means, such a junction or such type of piece of code is only people used to call it as hotspot. I would like to tell it as hotspot. Maybe many a times you may get it in the MCQs if you're attending the drives. If you're getting any MCQs like test in that, if they ask what is hotspot, don't feel that they are sharing you their Wi-Fi hotspot. What is hotspot with respect to Java? If any piece of code is if it is repetitively called, then we are going to call it as hotspot. And this hotspot is decided by whom? This is decided by the just-in-time compiler. Is that clear? Is that clear for everyone? So this is the basic overview of the JVM. So that's why I've given the overview of a Java architecture. So in detail, I'll be explaining the internal architecture of the JVM completely. I'll be explaining when the time comes. So for this class, let us quickly go to the notes and let us check it out. Okay. So till the just-in-time compiler we have done here. So this machine level code, I would like to write it in the next line. So this ML code, whatever we are going to get, will be used will be used directly will be used directly will be used directly for the repetitive method calls. For the repetitive method calls. Full stop. Maybe okay, so I've been stuck with something. Just a second. So the laptop was stuck. So in the next line, I would write like this. Just a second. The laptop has been hanged. Okay. So the problem with interpreter. The problem with interpreter is it will convert high level to low level code line by line, uh, which is time consuming. So that is the reason, the JIT came into picture. This problem can be overcome by the JIT. This problem can be this problem can be overcome by using just-in-time compiler. And one more fellow, I would like to call him as profiler. So what is the duty of the profiler? So responsible it is responsible to identify the hotspot and tell it to the JIT. So what is hotspot? Also you may get the question like this. So what is hotspot? The method, the method called, the method called multiple time, the method called multiple time is called as hotspot, is called as hotspot. Is that clear for you guys? So these notes, when you are writing in your book, so make sure that you read it once and write it, or directly write it, and please read it once. And while writing itself, you read it once, whatever the thing. So along with the diagram, when you read the things only, it will stick into your mind. That is what I can suggest. So let me continue with a few more things now. So it's giving me, what is the trouble? It's not taking the things from me. Oh. Now I can explain you the remaining features of the Java. So I would like to consider the eighth one, that happens to be robust. So if I want to speak about the robust, what do you mean by robust? The simple example that I can give happens to be all the superheroes, are like robust. So what do you mean by that? N number of time if villain hit to that particular hero also, 10th time you hit also, 11th time you will come back. So I don't know, some of the movies, there will be no logic at all. Even though if you buried that fellow inside a big graveyard, again he'll come back. I don't know what is the logic behind that. Just you have to watch it for the entertainment purpose. So if I want to tell what do you mean by robust, so robust is nothing but the system will not crash, the system will not fail. So it is very difficult to beat the fellow. So that is what we can in general will call it as robust. So how the Java is robust, I would like to tell it as maybe I would like to recommend Java is a highly robust language. So what is the reason also I'll be telling now. Highly robust, that means that is the chances of getting failure or the crashing is very less. It's very less. So simply, the Java will not crash. It is very robust because of two reasons I can tell, and I can tell like this. Because of the first one happens to be, I would like to tell you with the point. So it is a strongly typed programming language. Sir, what do you mean by this strongly typed programming language? See, in the Java, if you take a variable, I would like to tell it as example now. So if I want to take it as example, so I would like to write it in the next line. So I would like to tell like this. If you take a variable a, so you should be prefixing with the data type. That is what I can tell. So you should be taking the data type. You are going to decide whether you want the byte, the int, short, float, long, double, whatever you want, that you are going to tell. So that is the main thing. So for the int, if you want only byte, you can tell that it is a byte. So that's why it is called as a strongly typed programming language. So when I take up the data types, maybe in detail I'll speak on that. You'll be getting the complete clarity. But this is one of the feature why the Java is very robust. And the second point, if I want to tell, because of the concept that is present here, that happens to be the exception handling. So exception handling. So how we'll get the problem during the compilation, how we'll get the problem during execution. So what do you mean by exception? So what are the types of exception? How you can handle the exception? and what are the different ways of handling the exception. So all those things, this is not the right time to speak, but this is one of the important features that is available in a Java programming language. That is the reason, the Java is boomed like anything in the market when they have released. This is also a very important concept, as I explained in the multi-threading. So exception handling is also very, very important. So what is exactly exception, how to handle exception, so all those things, you'll be learning in the upcoming classes. So these are the two features which is very important, for the Java. So it became very popular. So any issues, in the system, it will be taken care in the exception handling part. So I would like to continue with the next one. So I will consider this happens to be the 8 point. So and I'll go for the ninth one. So in the ninth one, maybe I think I've taken it is distributive in nature. This is what you should be understanding it correctly. I would like to tell it as distributive. So what is this distributive? Maybe point in the later stage I'll be giving. So let us quickly go back to the screen now, the whiteboard, and I will explain what is exactly the distributive is all. Distributive is nothing but I can represent like this. I would like to tell it as this happens to be the ninth point. I would like to tell it as distributive in nature. The Java is distributive in nature. I would like to say the same thing. Java is distributive in nature. So let me change the color. Font size also I'll try to increase. What is this, sir? I'm not getting the point. Now listen carefully. I would like to consider two computers here, the client server architecture. So this is my client. So this is my server. So I would like to tell it as this happens to be the server. So, and I would like to tell it as this happens to be my client. So both are present here, well and good. Everything is going fine. But within this client and server, always the communication will be there. This also, the story. I need not to tell it. So in the day one itself, I've explained whatever you want, you are going to ask him. That is only we are going to call it as a request. So when you ask something, simply will not sit. If the data is present within him, so he's going to send what? He's going to send the response. Is going to send the response. Now listen carefully. So you have a response. Assume that your college result is what you got, and your USN number will be there, university seat number or hall ticket number will be there. So you're going to go to that particular website. If you're from VTU, you know that whenever result has been announced, immediately you will not get the result. Always the server will be busy, busy, busy like that. So in order to maintain, whenever the more clients are there, so in order to maintain what they are going to do, maybe one more fellow, your friend also will try to access to the same server. So I would like to call this fellow as maybe the client. So I would like to call him as maybe the client 2. So is what I can tell. So I'll be increasing the font. So this is my client 2. When client 2 also want to access the data from the same server, in case this server is already busy engaging, so what will happen? One more virtual uh, server will be present. So I would like to represent in a different way. So I would like to call it as one more virtual server will be present. So I would like to text it as, so this is server that is present. So whenever you have this particular busy, I would like to send the information here. First I will try to access to this fellow only. If this fellow is busy, what will happen? Immediately the request will be redirect to this particular server. Are you getting my point? So whenever this particular server is busy, this is going to redirect to this, and this person is going to process your information. So whatever the data that is available, and is going to send you the response. Is it clear for everyone? So I would like to rate it as here you have a request. So let me reduce the font. Let me reduce the size also. This much big is not required. Okay, anyways, listen now carefully. So you have a request here. The request, the response you should be getting. The response is what you are going to get it here. So from a different server. So you will not get that. So it will be happening in the background. So the piece of code will be present here also, the piece of code will be present here also, so that the complete application is distributive. So who is going to handle that, which server is busy, which server is free, so all those things, if you have a doubt at the back of your mind, so let me tell you that as well. It will be maintained by something called as load balancer. Load balancer with software will be running. He will decide whether this particular server is busy or not, this particular server is free or not. Don't get confused with the loader, the software that you have studied in that C program execution. Don't compare with the class loader which you have seen with respect to the JVM. This is with respect to performance of the server. Maybe when I was taking the software testing, so there is a separate testing called as performance testing. What do you mean by performance testing? Actually, they will test this performance. When you have any Facebook application, Instagram application, Ola or Swiggy, Zomato, millions and billions of people will be using this server, the company server, at a time. They'll be keep on sending the request, and they have to process. In case if one server goes down, have you ever noticed the Facebook server going down? Have you ever noticed that Instagram server is going down? It is not going to possible. You will not feel that if one server goes down also, one more server will get activated and you will start to respond. That is what I'm trying to tell you. So that will be balanced by load. Load means what? How many clients are accessing to your server? One client, two client, 1 crore client will be accessing to the server also. So that is only called as technically load. The load will be balanced by load balancer. For performance testing, in the software testing, there is a separate topic I used to explain that for my students. So any which ways, what is distributive in nature is what I want you people to understand. What is distributive in nature? The application logic, or I can tell it as app logic, right? In the day one, that app logic is distributive in multiple computer provided for the better service for the client. So I would like to go back to my notepad. If I go back to the notepad, so here I would like to tell the application logic. I would like to tell it as app logic. You can easily correlate. The app logic is distributive. The app logic is distributed. I can tell, it is distributed in multiple computer, or in other words server, to provide what? The ultimate agenda, to provide better service to the client. Ultimately, any company you're working, client, the customer is the god here. So I would like to tell the Java is very famous because of this feature also. It is very distributive in nature. Are you getting the point? So quickly we'll go for the next one. So today we'll finish it off this. So the next point is what I'm going to consider now. I would like to tell it as the 10th point. So that happens to be, it is having a very high performance, very high performance. So the reason, if you want to ask me, so I would like to tell it as maybe, um, even though the execution is relatively slow when you compare with the C, because of the just-in-time compiler, uh, I can tell it like this: since Java is using just-in-time compiler, just-in-time compiler, the performance, the performance, the performance can be, the performance can be increased. This is what I can tell. Apart from the just-in-time compiler, also so many features are available. Using multi-thread concept, the performance can be increased. Using this JIT, the execution speed will increase. If you write a standard code, obviously the performance will increase, and Java will support for that. That is what I can tell all about this. So it is going to provide so a high performance. So, and what are the next points I would like to take? Dynamic, yeah, very good. So the next one happens to be, this happens to be the very important feature. I would like to tell it as it is dynamic in nature. It is a dynamically typed a dynamic programming language. That is what people used to tell. So what do you mean by this dynamic programming language, if you ask me? So I have one answer, but the explanation, so you have to wait it for some more days. So what I can tell, if I consider as the a static programming language, I would like to tell it as a static programming language. So what is the static programming language? In the static programming language, I would like to consider as like a C++, what will happen means memory allocation for primitive data type, for primitive data type. That is what I've told. Data type I have now started. In the primitive data type, it seems the primitive data types which is present in the C and C++. So for that, memory allocation will happen during the compilation phase. I would like to tell it as memory allocation for primitive data type. Primitive data type will be during compilation time. It's during compilation time. If I want to speak about this, I have to write the memory diagram for that. So, and I need to explain what is exactly data type. In that, what is primitive data type? Primitive data type, how the memory will be allocated in the memory segment, especially in the heap segment. All those things. If I want to tell, so today it's not the right time, but just the points is what I'm giving. I would like to take that dynamic programming language. Just a difference is what I'm giving today, so you can make a note of it, the language. So the Java, and not only that, your Python programming language as well. So what will happen, the memory allocation, whatever that is present, so it will happen during which time, if you ask me. I would like to call, and I would like to delete this one, just a second. Yeah, Java and Python, the memory allocation for the primitive data type will happen during the execution phase. I think in the previous class in one diagram I've shown how the compilation phase will be there and execution phase will be there. So for this particular, during the execution time, the memory allocation will happen. Again, certainly 100% clarity I cannot give it here because of the one reason. So to explain this, to give you 100% clarity, I have to write the memory diagram. So this is not the right time. So let me continue with the last point. I would like to call this one happens to be the secured. So what do you mean by secured? So Java itself is a secured in nature, people will tell. So what do you mean by that? It is secured in nature. So because of the bytecode verifier that is present here, so before the execution part itself, so it will check whether the piece of code is secured or not. I mean to say, any virus is there or not, or is that check compiled by a Java compiler itself or not. Completely, it is going to check. And I would like to tell it as Java consists of bytecode verifier. Bytecode verifier. Today's class itself in the JVM we have studied, right? So Java consists of bytecode verifier, so which will check the bytecode is compiled compiled correctly or not. Hence, provide security for the program. Security for the program. So this is what I can tell about why Java is called as a secure programming language. Still, few more points will be there, with along. I'm just giving you the glimpse with respect to the features. So I would like to, by giving these points, I like to end up the features of the Java. Let me quickly go above and let me call all these things. So I would like to consider the platform independent. You know that. What do you mean by interpretive byte coded? It is simple, architecturally neutral, portable programming language, object oriented, multi-thread, robust. You know that because of the strongly typed programming language, and because of the very important feature, that is exception handling. And why it is distributive, So app logic, they are going to distribute around different computers to provide the better service. So high performance because of just-in-time compiler. So it is dynamic in nature because of the memory allocation. So and it is secured because of the bytecode verifier. And today we have studied something called as the Java software. So in the Java software, what are the things you have studied? So in the Java software you have studied, it has been divided into two parts. One is JDK and one is JRE. JDK for the development kit, JRE for the execution part. And JDK itself is consist of JRE, and inside the JRE you'll be having the JVM. JVM is a Java virtual machine, which is a machine dependent, but it will do many tasks. Many tasks. JVM is going to act like a loader by making use of the class loader, and not only that, along with it will do the many tasks. Bytecode verifier also present in the JVM. It will check the code is correctly compiled or not. And you have something called as execution engine. So in the execution engine, what you're going to do actually. So three things are very important. It will act like an interpreter. JVM will act like an interpreter. So along with that, it's have something called a just-in-time compiler. When a method calls again and again, instead of going with the interpretive mode directly, it will consider it as a hotspot and it will convert into the machine level language in one go. So who will decide that? It is decided by the profiler and tell it to the just-in-time compiler. And the same points I've repeated. So let me quickly go to my whiteboard. In the diagrammatic form I want to show it. So today we have started our discussion with this. Java has been classified for development and execution. This is the program, what is happening on the RAM. So after that, this is the complete JDK, insert the JRE, insert the JVM, and this is what I've expanded and I've told you few points in that. But in detail, JVM architecture, I will explain the internal in detail architecture. I'll be explaining as and when the time comes, and it will be having some developer tools as well and the library classes. And if someone asks what is JDK, JRE plus developer tools, JRE happens to be JVM plus library classes. IDE is what we require to type the program. We can use Eclipse, Notepad++, only the Notepad or the Edit plus. So it doesn't matter. So type it and execute it and write the programs. So overview of the Java architecture, Java program high level language, compiler, bytecode. When you want to load, separate loader is not required. Class loader is there. To check, bytecode verifier is there. To interpret, interpreter is there. Just-in-time compiler, when you call again and again, so it will count. The profiler will do this counting activity, create the hotspot, tell it to just-in-time compiler, then it will convert in one shot. So it will increase the performance. And not only that, maybe I have shown you what is distributive in nature. These are the diagrams. So I hope you people got a complete clarity on the features of Java. So why you have to learn the Java programming language in the beginning class itself I have discussed. But these are the 12 Java features which is very very important. Any interview you go, these features you should be knowing as a general knowledge. Otherwise it will be very difficult. So installation video also already have been released. So how to download the JDK, how to set up the environmental variables. After setting environmental variables, how to type the first Java program and execute, how to do it in the notepad, and how to see it in the command prompt, the output. And along with that, edit plus software also. I had given you the software, the link in the installation video itself. So how to download the edit plus, how to configure it actually, and how to start typing the programs. So once our program started, it's every day it's a program. So I'll be starting with upcoming topics. So what the data types or the language fundamentals, all those things are available. So let us continue with our regular class. So for this particular session, I want to conclude the Java features, the remaining points from 8.8 to 12, the four things, because till 7 I have completed. And along with the Java software, the JDK and JVM is what I'm supposed to explain, and I've done it. I hope that you people are watching my videos regularly. Do watch it, tell it to your friends also, and do support the study online. Attend the classes regularly, because again I'll tell you, once the time if you waste, again you will not get it back. If you spend money you can earn back, if you spend time you cannot get back. So that is the fundamental of life. So by telling this, as normal, I'll tell the same thing. Day without learning the new thing, so it is the day wasted. Learn the things with the passion. So it's already, I think, 3:52. Okay, 4 o'clock early in the morning. Still, I'm doing working on it. In which ways, attend the classes regularly, and my classes will be, that is what I'm seeing, 4 p.m. Actually my class will be there evening every day. 4 p.m. my class will be there, and 4 a.m. still I'm doing the class now, recording. So take care, write the notes, revise, type and execute,